Hi, this is Miss Claywell here. We are starting Skill 19, Arithmetic Series. So we know that arithmetic is like adding, when there's a pattern that you're adding. But we need to talk about what a series is. So a series is the sum of the terms of a sequence. So for example, if I was like, adding 3, 5, 7, and 9, if I summed those or added those, that would then become a series. So 3, 5, 7, 9 would be considered a series. Or 3, 5, 7, 9 is the sequence, but once we add them, it becomes a series. And then a finite series is when we add a set number of terms in a sequence. So meaning there's like a starting point and a stopping point. So if we were to sum the first 7 terms, we'd write that S of 7. So that means like find the sequence of the first 7 or add the first 7. So we're going to go ahead and look at this once the 5th partial sum. So it wants us to add A1 plus A2 plus A3, A4, and A5. I know A1 is 3. A2 is A1 minus 2 squared. A3 is A2 minus 2 squared. So I would find the sum of the first 5 is 3 plus 1, 2, 1, 2, 3, plus the first 5 terms, which would get me 7. So that's basically the idea of adding or series, is when you take the numbers of the sequence and you add them. So next we're going to look at this idea of sigma notation. So sigma, we can think of the S as like sum again. This symbol that I'm circling now is the means to sum. That's like the sigma. So this is telling us to start at 1 and add the first to the 4th value. And we're just summing. The operation is n. So this is like the first term, the second term, the third term, the 4th term. So it's telling me I'm starting by putting a 1 into the formula, and then I'm going to put a 2 into the formula, and then a 3, and then a 4. And my formula is just n. So if we look at the example where I'm starting at 0, and I'm stopping at 3, I'm plugging a 0 into k, a 1 into k, a 2 into k, and a 3 into k, and that's what we see here. So this is like the first term, or the 0, first, second, and third, and that would sum to 6. So now it's asking us to form the first to the 5th of each of these. So I want to have when I equals 1. The first term is 2 times 1 plus 3. I want when I equals 2. And I need to go to the when I equals 5. Basically, and we can also see that this is arithmetic in the sense we're adding 2 to go from each term. So now I need to sum A1 to A5. So the sum of the first 5 would be 45 if I added all those, or this equals 45. So here I'm starting at 3 and I'm stopping at 6. So I need to have n equals 3, n equals 4, n equals 5, and n equals 6. So 3 squared plus 2, 4 squared plus 2. Then I need to sum the third to the 6th, and that would get me 94. So what if we looked at a series that's having us go from the 1st to the 75th? That would take a lot of time to have to add the 1st, 2nd, 3rd, 4th, all the way to the 75th. So this is lots of work. So instead, we have a formula. Where we can sum arithmetic series by A1 is the first term value, AN is the last term value, and n is the number of terms in sequence that you want to add. So we're going to go ahead and do this first, the 71st one. And we're going to use that formula. So y is a series arithmetic. Let's list the first few terms. So like A1, I see is 3 minus 2. A2 is 4. So we have 1, 4, 7. We're adding 3 each time. So n, I want to add 75 terms. My first term is 1. What is my AN? So I want 8 of 75. If I put a 75 into this equation, I end up with 223. So now I'm going to use this. So the sum of the first 75 terms equals n, A1 plus AN divided by 2. So the sum of the first 45 terms of 3n minus 2 is 8,400. So this one wants to know the sum of this arithmetic series. I'm starting at -2 and I'm adding all the way to -41. So I know my first term is -2. I know my last term is -41. I know to use my formula. Remember, my formula is NA1 and AN. I don't know my N yet. I need to find. But I do know my D is -3, so I'm adding a -3. But what I can do is I know AN is 41. I know AN is -2. N minus 1 times my -3. I can then find my N. Oh. And as I work through to solve this, this goes up to here. I have -3n plus 1. Divide both sides by -3. And I get that n equals 14. So now I have all the information to sum the first 14. So my sum of 14, the first 14 terms. That gets me -100 or 301. Now, some of your Delta math problems will maybe ask you to write this in sigma notation, write this series. So we're summing the first to the 14th term. And we found that, I'm going to use a different color. When we did our a to the n equals a1, which was -2 plus n minus 1 times -3, this simplified to -3n plus 1. So that's like the operation that we're performing. So we're summing the first to the 14th of -3n plus 1. The last example, you go to visit the Grand Canyon and drop a rock off a cliff. In the first second, the rock falls 16 feet. The second 48, and then 80. So it wants to know the distance it fell in 6 seconds. So let's think about what it gave me. It gave me A1 equals 48. A2 equals 80. Sorry, I'm off. It's 16. So we're seeing that our D equals 32. We don't know. We need our A if we want to use the formula Sn is n A1 plus A n divided by 2. We don't know our A6. So we're going to do a little work to find that. So with that, our A4 equals negative 112. Our A5 equals 144, and our A6 equals 176. So now I can do S of 6 equals I of 6. My first term plus my last term so remember to write this as a sentence. It fell 576 feet in the first 6 seconds. So that's all for skill 19.